All right, well, welcome back, everyone. So this is going to be our last part for this ventilation physiology set of lectures. And what we're going to look at, we're going to look at the some numbers and some figures and some kind of ideas related to moving air into the lungs, right? So this term here called minute ventilation. This is simply the amount of air that's moving into and out of the lungs, so reaching the alveoli in 1 minute, right? Um, when you look at this in terms of one breath, this is called the tidal volume, and we'll talk about tidal volume here in just a little bit, usually somewhere around 500 milliliters, right? So the way you can approach this is almost think of this as kind of like stroke volume and cardiac output, right? So remember, stroke volume was how much air, or I'm sorry, stroke volume was how much blood was leaving the heart in one contraction, right? So that's kind of like tidal volume, right? How much air do we move in and out of the lungs in one breath, right? So maybe we inhale 500 milliliters, right? That's like the stroke volume, right? How much blood leaves the heart in one beat. Cardiac output, remember, was how much blood leaves the heart in 1 minute, right? So minute ventilation is kind of like cardiac output. So you take how much air you move in one breath times the number of breaths, and then you get some number, right? So how many milliliters or liters of air do you move in a single minute, right? So something like 500 milliliters per breath, so tidal volume, times 12 breaths a minute, that's 6,000 milliliters or 6 liters per minute, right? So think of it as the equivalent of stroke volume and cardiac output, right? Now, for our minute ventilation, not all of the air, and whenever we inhale, not all of that air reaches the alveoli, right? Some of it ends up staying in the terminal bronchioles, respiratory bronchioles, alveolar ducts, right? And so this term called anatomic dead space is this conducting zone space in which air remains during ventilation and it doesn't reach the alveoli. So there's no exchange of gases, right? So that's maybe somewhere around 150 milliliters per breath, right? So it goes in through the larynx, oral cavity or nose, pharynx, larynx, trachea, primary, secondary, tertiary bronchi, bronchioles, terminal bronchioles, but it never quite reaches this respiratory zone, right? And so there's no exchange of gases, right? Alveolar ventilation, as we kind of mentioned, that's the amount of air that actually is reaching these alveoli and is capable of being involved in gas exchange, right? So the rate of airflow in and out of functioning alveoli only, right? And then that gas that is involved in alveolar ventilation can be involved with gas exchange, right? Now, there's another term that's related to anatomic dead space, and this is physiologic dead space, right? So this is the anatomical dead space, right? So again, the air that stays in parts of the conducting zone that doesn't participate in gas exchange, plus the amount of space that is lost whenever we have damage to alveoli, right? So again, pneumonia, emphysema, something like this, in which we're destroying the respiratory membrane, we have lost our alveoli. When you add that amount of space, that volume, to the normal anatomic dead space, that's called the physiologic dead space. So basically, how much total space in the lung is there and how much air is there that's not participating in gas exchange, right? So exchange of gases between the blood and the lung, right? So we can also look at some very specific volumes related to breathing, right? So you can use something called a spirometer, and this is aiding in determining specific values for the amount of air that we inhale and exhale, right? So this first one is called tidal volume. This is simply how much air do we inhale or exhale in a single breath. And we mentioned this earlier, somewhere maybe around 500 milliliters, right? So you inhale, you exhale, how much air left or went into the lungs during each of those. So when you inhale, that's tidal volume inspiration. When you exhale, tidal volume expiration, right? The inspiratory reserve volume is how much you can inhale above and beyond what you normally do. So you take in a breath, and then you try to breathe in even more on top of that. That's called your inspiratory reserve, right? Your expiratory reserve is the same thing, but for exhaling. So you inhale, you exhale, and then you try to forcefully exhale out even more. That's your expiratory reserve, right? The residual volume is the amount of air that's left in the lungs after you forcefully exhale, right? So exhale, so inhale right now, inhale, and then exhale, and keep exhaling and try to exhale as much as you can. After you've exhaled as much as you can, the amount of air that's still in your lungs is called the residual volume, right? So there's always some amount, okay? You can take multiple of those volumes and add them together, and you get capacities, right? So inspiratory capacity is just the total amount that you can inhale. So tidal volume inhalation plus your inspiratory reserve. Functional residual is the amount of air that's left in the lungs normally after you exhale. So you inhale, you exhale. After you quietly exhale, how much is left, right? So that's the expiratory reserve, so the amount that you could exhale, plus the amount that you can't exhale, which is residual volume, right? And then vital capacity is your total amount of air that you can move in and out of your lungs. So that's your tidal volume plus your inspiratory reserve plus your inspiratory reserve and expiratory reserve, right? Total lung capacity is the same as vital capacity, but you add the residual volume, right? So the maximum volume of air that the lungs can hold, this is the amount of air that the max amount that a person can exchange. So remember, this is the same thing, but add the residual volume, okay? So you can look at forced expiratory volume as a function of general respiratory health, right? So the percentage expelled in 1 second. So what percentage of air can you exhale from the lung in 1 second? So maybe somewhere around 75 to 85% of your vital capacity in a healthy individual, right? Less with emphysema because there's some air trapping, right? So things like COPD, chronic restrictive pulmonary disorders, in which there is a decrease in this FEV, right? This forced expiratory volume, right? So you can take all those volumes and all those capacities, and you can simply plot it on a graph like this, right? So you see tidal volume, right? How much do you inhale? How much do you exhale, right? How much do you inhale? How much do you exhale? You can see inspiratory reserve. So this is how much you inhale, and then this is how much you inhale above and beyond what you normally do, right? You can look at ERV. This is how much you normally exhale. This is how much you exhale above and beyond what you normally exhale, right? Here's your residual volume, right? So this is 1,000 milliliters or so. This is the amount that's left in the lung all the time, right? Even after you forcefully exhale as much as you can. The amount of air that's left in the lung normally after you're done quietly exhaling is this functional residual, right? So ERV plus residual volume. The amount of air that you can totally inhale is your IRV, right? So your inspiratory capacity, so normal tidal volume inhalation and your inspiratory reserve. Your vital capacity is IRV, ERV, and tidal volume. And then your total lung capacity is the same as vital capacity plus residual volume, right? And you can look at some of the figures down here, and what you'll see is that often the figures are larger. They're greater values in males than in females, because on average males are larger, they have larger lungs, they're able to establish larger pressure gradients due to bigger changes in volume, thus bigger changes in pressure, and so their respiratory volumes and capacities are typically a little bit larger, right, than the females. And so you can go through and you can see some of those, right? So this is where we're going to leave off for our ventilation physiology set of lectures. Reach out if you have any questions. In the next set of videos, what we're going to look at is we're going to focus more on gas exchange.